We learned that there are two unicast address. One is global unicast address. Another one is link local unicast address. The global unicast address is for global reachability, for you and me to ping. The global unicast address starts with 2000 range, 2024, 2002, 2001. That is global unicast address. For example, you see, nowadays it is totally IPv6. Did I say to use IPv6? No. Automatically, internet is already moved to the IPv6 world. Don't think IPv6 is yet to come. It is already here. You saw me pinging YouTube, but you see which server is responding? An IPv6 server. And you see the address of YouTube, 2404. Let's ping Google. Even this is also 2404, but only this portion is different. The subnet portion is different. Why? Because YouTube also Google family only. All Google family will have this one same company. Only the subnet is different. See, you were asking, teach me subnetting. What is nothing here? Put different number, you will get different network in the fourth octet. There is nothing to teach in IPv6 subnetting. This is the ID given to Google. For every single service, they will have different number here. That's all. Now let's say ping www.yahoo, different company. This portion is totally different. For a different vendor, this portion, if they are from same geographical location, you see, this and this, oh, even this is also not same. So geographically, this is not same location. If it is geographically same location, this portion and this portion will appear same. This is 68, Google family, Yahoo is 86. And this portion is for Google, and this portion is for, sorry, this for the location, different location. This is for Google, 4009. This is for Yahoo. In that Yahoo, this is the subnet. Let's see Facebook. This is totally different. 2A means 2000 series only. A means 10. In hexa, A means 10. Totally different. Different location, different vendor. Now, what am I saying? I'm saying all starts with only 2000. Global unicast address will start with 2000. Okay. You see, the link local address. Let's continue. Now, both the address are unicast address, but the link local address, the purpose of this address is different. The link local addresses are for neighbor discovery. Good question. You cannot do it. You see, in IPv6, we don't have this. In IPv4, we don't have this concept of having a separated, dedicated address for neighbor discovery. In IPv4, you don't have it. That is not good. Missions to know each other, routers to discover themselves, missions to know each other. They need to have a dedicated address. What is wrong in having a common address like IPv4 address? The problem is this: we use the same address to discover neighbor. The address that you use for communication, the packet forwarding, the address that you use for communication, the packet forwarding, SSH, HTTP, etc. You also use it for neighbor discovery. What happens? Your identity is revealed to the entire world. But for the device identification, if you have a dedicated address, if you have a dedicated address for device discovery, then you won't have that problem. Secondly, for example, ARP, the service ARP is one example. To prove that IPv4 has got some flaw, IPv4 has got some issue. What ARP uses? It uses layer 2 broadcast. ARP uses layer 2 broadcast. With that layer 2 broadcast, it is going to discover the MAC address of the device whose IP address you have broadcasted, which is bad. Broadcast is bad. And when you learn MAC address for an IP address, everyone knows that, oh, this is the IP address, this is the MAC address of this device, which is danger, not good. So, what is the solution? IPv6 is coming up with a new address called linked local address, which is not there in IPv4. So don't relate this to any private address of IPv4. Don't compare this. I also want to remind you that there is no private IP address on IPv6. In the previous class, I told you FEC0, FED0. They were called a site local address, but that is deprivated. It's no more. I told you in the previous class. Earlier, they were thinking like, oh, we need some privacy. We need some private address. So they say FEC0, FED0 we'll use. Privately we'll use. But later, they came to a conclusion that no, we are not going to allow the people to have any privacy. If they want to use the internet, which is a public network, they need to be in public. That is good for everyone. But if they want security, let them buy the firewall. Still, they will be visible to everyone, but their data will not be visible. They can use some encryption method, they can use firewalls to encrypt, they can use firewalls to protect their network. But like IPv4 hide and seek game, we will not play. In IPv6, no hide and seek game. Fine. About this link local address, as I told you, this address is only for neighbor discovery. Okay. Go out of your house, and if you find one star, and if you say that star is the starting star, find the ending of the star and tell me, then I'll tell you the answer for this question. Same answer only. No one knows. No one on earth knows what is the last IP address in IPv6 address. Hmm. Hmm. That is also a nice question. Salt is very important for food. If no salt, no food will be tasty. Whatever you may put cashew nut, you may put anything that you want, but still, if you don't put salt, do you pay for the salt? Same way, you have to buy IPv6 address. But the salt is not costly, you see. Why? Because salt is everywhere in the ocean. 3% of Earth is water. So you got plenty of salt. So some people do the refining thing and give you in a crystal form or in a powder form. Only for that crystal form, powder form, refining, you are paying. Not for the salt. Salt is free. Likewise. IPv6 is big like an ocean. Too much. We discussed how big it is earlier. So it won't be costly, it will be cheaper because the service providers have to give you a dedicated address without conflicting with everyone anyone else. For those things, they need some service charge. That IANA divides the address in region wise. They all need some service charge because they give you a guaranteed address which will never conflict with a new one. So you have to pay. But it won't be costly like IPv4. IPv4 is like a cashew nut. You ask Mithun sir how much it costs, he will say, good cashew nut 1000 rupees, sir. Broken, maybe 800 rupees. But salt is not like that. Thank you, sir. Salt is not like that. 1 kg maximum, even if you go to some big company vendor salt, end of the day, salt is only from ocean. But if you go to Ata, Kuta, Pata, then you will have like 15 rupees 1 kg. That's all, not much. So IPv6 is not costly. It's not a cashew nut rate. It is only salt rate. It is important. Without salt, no food. Without IPv6 address, you will not have AI. You will not have AI as a member of parliament. You will not have AI as a prime minister in future. You will not have chief minister in future. AI machines as a chief minister. Soon it is going to happen. It is all because of this salt IPv6. Now, this address starts with FA80 only. But you see here, IPv6 address is 128-bit, both link local address as well as global unicast address. You should not say public address. You should say what? Global unicast address. because there is no concept of private, public, all public only in IPv6. IPv6 all public only. Now, link local address. 64-bit is only this much. It will never change. For example, you see FE80 0000000000. This never changes for link local address. This never becomes any number. Only 000000. But the other 64 will vary for every interface. Understand? It's an interface ID. See, on every interface you have what? MAC address. We have MAC address on every interface. So this MAC address is going to be added in this portion of 64-bit so that this address will be unique. It won't conflict with anyone. This address you're not going to purchase. This address is like a water which is already in the vegetable. It's coming free with the vegetable. Take tomato, there will be water in it. Take brinjal, there will be water in it. Take carrot also, in carrot also you will have water. But carrot is different, brinjal is different. Likewise, this portion MAC address is different. Interface G00 link local address, interface G0001 link local address will not be same. Why? Because the interface portion is MAC address. Is MAC address. Because the MAC addresses are unique, the link local address also will be unique. Now coming to this portion only, I'm going to focus on this portion. MAC address is only, you tell me what I was telling now. MD, MDs. Link local address is different, interface ID is different, or interface ID is a part of link local address? Oh, this man, he will make one wrong statement and then he will try to make it as a right statement. He won't agree. Oh, I'm mistaken. Ah, ah, ah. No, no, no. What is the size, my dear? What is the size of address in IPv6? Size of address is 128, no? Is link local address or something else? My dear, I don't want that. Is link local an address or anything else? Address. Then what is the size of that link local address? 128. Now you tell me, is this two different address or same address? Hmm. Ah. Hmm. 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 Oh my God! Stop it again. This is what link local address, not this. You are repeating again, same mistake. Address is 128 only. This is that link local address. In that, first 64 bit of that address is always this for any router, any switch, any computer, any interface. This will always be same. And the other half of that same address will not be same. Why? The other half is called as interface ID, which is going to use the MAC address on the interface so that the address, the whole address will be unique. It won't conflict. You got it? Uh, Now coming back to this interface ID. This interface ID is 64 bit. But what is the size of MAC address? Only 40. Then how can you make it a 64? Like this. They take that MAC address and cut it into two half exactly, and in the middle it is always it is always FFFE. What is the size of FFFE? Very good. 4 plus 4 plus 4 plus 4, 16 bit. So 48 plus 16 bit is how much? 64 bits. 64-bit interface ID. You understood? So what is added to the middle of the MAC address to make it as unique? FFFE. FFFE is added. Next is, you see here it is 0. Here it is 2. Other things are correct, perfectly matching. 0A, 27, 5C, A88. Why it is like that? Because universal local flag of the link local address is the 7th bit, which is supposed to be 1 only. But here it is 0. Again, I repeat, for the sake of link local address, they said that 7th bit should be 1 only. But if I take MAC address, if I take this MAC address and write it in binary 0000 0000 0000, A, how do you write? A is 10, 10 is 1010. Now, 7th bit, which means this bit, I'm changing it as 1. Now you say 0000 0010. This 0 is 0. This is 2, isn't it? So this 00 is turning to 02. This 0 is same, 0. This is A, same, no change. That is how you got 2 here. Because the 7th bit should be flipped to 1 so that universally it will not conflict with any of other technology, VMware technology, etc., which is existing in the real world already. So they say, okay, you see, if you don't change this seventh bit to 1, it is creating some issue with the previously given MAC addresses to companies like VMware, some virtualization companies. To avoid such thing, they made this as a local flag need to be flipped from 0 to 1. This is how this unique identifier, what is the unique identifier? MAC address has been extended unique identifier. This is how the MAC address is extended to 64 bit. Yeah. So that's the explanation for this. I'm going to quickly show you this. That will be the gateway for this network. On the other side, 2000 colon 2 colon 2 slash 64, and here 2000 colon 2 colon 1 slash 64. You see, we have only the global unique address, but the link local address will auto generate. You see, IPv6 automatically it is already there. You see, link local address FE80 starting with FE80. This portion you see right in the middle. You see what is that you see here? FF FE. That's what even you saw here. FF FE. Always it is FF FE added in the middle of the package. And you see it is 2. Leading 0 is omitted, so it's 2. Okay, I'm going to say 2000 colon 1 colon 1. Prefix length is 64. Gateway 2000 1 colon 2 slash 64. Sorry, no need to put slash the gateway. Okay, let's verify. ipconfig /o. You see, I have given an IPv6 address, and the link local address is this, and the gateway address is this. Now going to the other last PC, and then I'll come back to the router. Two thousand colon 2 colon 1 slash 64. Gateway is 2000 colon 2 colon 2. Right. We have the IP addresses. Let's do the router side configuration. You see on the router, right now you will not have any link local address. In the PC, you saw link local address is already ready. It was ready to use, right? In the router, you won't see. In the router, it will get generated only when you configure global unicast address. Let me show you. See, using router is easy for IPv6. If you know IPv4, IPv6 is easy. Say for example, to check the interface status, you use to type show IP interface brief. Here, show IPv6 interface brief. You see, there is no link local address, there is no address assigned administratively done. Let me bring those two interfaces up. Even now, the link local address will not come. Do you see any link local address here? No. Link local address will only appear when you configure these global unicast address. Let me do it. Interface G000 IPv6 address 2000:1:2/64. Interface G0/0/1 IPv6 address 2000:2. This is different network :/2. Sorry, :2/64. Now, if you go and see, you will find a link local address. Show IPv6 interface. You see, for this is the link local address. Are they same? No. You see, the last number is not same because the MAC address on these two devices, one ending with 1, another one ending with 2. That is why. The link local address, you no need to configure. It automatically gets generated. But if you wish to configure it manually, it is possible. But there is no need for it. We'll talk about that possibility and all later. Now let me try pinging from here. I'm going to ping the last computer. Ping 2000:2:2. Sorry, 1. Isn't it? 1. No need. 2000:2:1. Why the ping is not happening? Any guesswork? Why the ping is not happening? This PC even have a gateway address. Right? And the IP address is also correct. Then why it is not pinging? It is because by default the routing is not enabled for IPv6. So we have to put this command IPv6 unicast routing. After this only the routing table gets generated. Show IPv6 route. You see, this is the routing table. Now let us ping. Okay. Now let's ping. Not even single packet lost. If it is IPv4, we might have lost at least one packet for ARP. Here there is no ARP. Already neighbor discovery happened using the link local address. Then why there will be a drop? That is why you need link local address. Before you ping, they keep all the things ready in the table. So when you ping, no drop. Let me show you. Show IPv6 neighbor. You see, using link local address, it has already learned the MAC address of the neighbor device. It is using the link local address it learned. As a result, the very first packet itself will ping. There won't be any delay because it's not going to say, hey, get up. I don't know the MAC address, go get it. Nah. Before you ping, it knows the MAC address. Using link local behind the screen, they do the work and keep it ready. That's why you need separate address for the machines to use. Talk. I'll stop